Okay, FLSM, fixed length subnet mask. Let me just get this one here. It is a subnetting method. Every subnet has the same subnet mask. Now look at here very carefully. What it says here, every subnet has the same subnet mask. What do you mean by same subnet mask? So every subnet, if they have /24, then all the subnets will have /24. If they are /25, everyone will have /25. Every subnet has the same number of hosts. So if one subnet has 14 hosts, the other subnet will also have 14. If one subnet has 30, the other subnet will have 30 as well. Like this number can vary, but as I mentioned, like they will have the same. It is opposite to VLSM. What is VLSM? Variable length subnet mask. So every subnet will have different lengths. Every subnet will have different lengths. Okay. So one can be /24, other can be /25, one can be /26, other can be /27. Do we use FLSM? FLSM is used when all departments need equal number of hosts. When all departments needs equal number of hosts. So for example, you will get a question something like this. If okay, we have four departments, and each department needs, let's say, 30 IPs or 30 hosts, okay, or they have 30 computers, PCs. And the network design is fairly simple because everyone will have the same. Okay, just make sure that you have a big room and you will divide it into 4, okay, of equal size where 30 people can sit. Okay, now look at here very carefully. Let's say this is the network address, so you will be given a network address, or you will pick a network address, and you need to create 4 subnet. The formula is 2 to the power n greater than or equals 2. Okay, so you need to, let's say for example, if they say you need 3 subnets, okay, so if you need 3 subnets, actually you can't get something like 3 subnets. So you can get either 2 subnets or you can get 4 subnets. So 3 falls in between them. So that is why I said greater than or equals. Okay. So if you look at here, according to the question, we need 4 subnets. N is the number of borrowed bits from the host bits. So if you look at here in this question, the /24 means there are 24 network bits and there are 8 host bits. So you are going to borrow 2 bits from the host bits. Okay. Now if you look at here, 2 to the power 1 is greater than or equals 4. Borrowing 1 doesn't work. Okay. Borrowing 2 to the power 2 is 4, greater than or equals, okay, 4. That works. So borrowing 2 bits, it works. Borrowing 1 bit, it doesn't work. Now look at here. We will borrow 2 bits from the host bits. We will borrow 2 bits from the host bits. Borrowing host bits means putting them into the network bits, and you will need to form the networks. So when you borrow, let's say for example, this is your network bits portion, 24, and this is your host bits, 8. When you borrow 2 bits from here, this will become 6 and this will become 26, and this will extend, whereas this will shrink. Okay, 2 bits from the host bits. Borrowing host bits means putting them into the network bits, and you will need to form the network. You need to form the networks. Okay, so when you borrow 2 bits, you can form 4 networks. The formula is 2 to the power 2. We'll have a look at that. Borrowing bit will increase the size of the network bit and will decrease the size of the host bits. In this example, you have 8 host bits, 24 network bits. If you borrow 2 bits from the host bits, you will be able to produce 4 networks because the formula is 2 to the power n, and you will left with 6 host bits. So if you look at here, then why do we borrow bits? Because borrowing bits create more network. Each bit you borrow doubles the network. Like for example, if you borrow 1 bits, you will create 2 networks. If you borrow 2 bits, 4. The formula is very simple. The formula is 2 to the power n. Okay, 2 to the power n is the formula. Based on that, you can do that. So when you borrow 2 bits in our example, 192.168.1.0/24 will become 192.168.1.0/26. Why? Because you borrow 2 bits from the host portion, so that is why host portion got small. Host portion got small. So that is the one that is happening here. Now, if you look at here very carefully, 24 becomes /26. The difference is in the 4th octet. Where the difference happened? The difference happened here in the 4th octet. The difference happened in the 4th octet. So /24 became /26. And with the 2 bits, you can produce 4 networks, 0, 0, 0, 1, 1, 0, 1, 1. It happens in the 4th octet. So if you look at here, it happens in the 4th octet. And which 2 bits happened? These two. These two, these two, these two. Here it happens. Now look at here very carefully. It is now /26. It is now /26. Okay. It has become now /26. Before it was /24. It has now become /26. And that is why, if you look at here, if you do the network address, all host bits zeros. So you only these 6 bits are zeros, it will be 0. So these two will be the network portion now. These two will be in the network bits portion, and these 6 is the host bits portion, is the host bits. Okay, is the host bits. According to the formula, what is the network address? All host bits zeros. And what is the broadcast address? All host bits ones. Now, if you look at here, if you make them 0, 192.168.0, 64, because why 64? 0, 1, 64, 1, 0, there are 4 networks. Now look at here, when you borrowed the bits, you formed 4 networks. Now, everything is fixed. You cannot make any changes anywhere, okay? There are 4 networks and you can make changes only in the 6 bits. Previously, you could make changes. Before you borrowed the bits, you could make changes with all the 8 bits. Once you borrowed the bit, you need to create networks based on how many bits you borrow. Once you have done that, then you cannot do anything in these 2 bits because they are fixed. They are network bits. With the network bits, you cannot do anything. So only you can make changes in the host bits, and they will be /26. Previously it was /24. So if you look at here, I divided this /24 into 4 equal networks. So if you look at here, 0 to 64, 64 to 128, 128 to 192, okay, into 4 equal networks. Okay, so if you go so from 192, the end will be we are writing only the network address. Now look at here very carefully. The subnet 1, this is the network address, and this is the broadcast address. These are the usable host. For subnet 2, this is the network address, this is the broadcast address. In between you have the usable host. For subnet 3, this is the network address, this is the broadcast address, these are the usable. Okay, when you move from /24 to /26, we borrow 2 bits from the host portion and give them to the network portion. That's right. With 2 bits creating 4 different subnet combinations. That's right. Each subnet has got 6 host bits remaining. That's right. Each subnet has got 6 host bits remaining. That's right. To calculate usable IP address, we use 2 to the power the number of host bits minus 2. Now look at here very carefully. The formula is very simple. The old formula, which is 2 to the power h minus 2, 2 to the power the number of host bits minus 2. Okay, so we subtract 2 because the first address is the network address and the last address is the broadcast address. So and this cannot be assigned to a device. Okay, this cannot be assigned to a device. So 2 to the power 6, because you have 6 host bits here, you have 6 host bits here. So 2 to the power 6 minus 2, 64 minus 2 is 62. So you can, if you look at here, from 1 to 62 you can use 62. From 1 to 62 you can use 62. It is important to remember that the broadcast address will always be odd numbers and the network address will be even numbers. So if you see here, the broadcast addresses are odd numbers, the network addresses are the network addresses are even numbers except for the 0, because of course 0 can be a network address as well. Apart from that, all network addresses must be even number and all broadcast addresses will be odd numbers. So if you don't find that, that means you made a mistake somewhere. So if you don't find that, you made a mistake somewhere. Be careful with that one. Example 2, the same thing. They need 8 subnets. Usually in the question you will find 8 subnets with let's say 10 IP addresses, 8 subnets with 16 IP addresses, something like that. But I want you to learn how to divide, and you can do the calculation of number of IP addresses as well. So for example, look at here. If the question had been here, they said 4 subnets. If the question had been something like this, you need 4 subnets and each subnet will have, let's say, 500 hosts. So in this case you cannot use class C. Class C cannot be used because class C can produce only 256 IP addresses, and if you subtract 2, then it will be 254 IPs, and that is only 1. So you cannot use class C, okay? So you need to use something like, instead of class C, class B, okay? Now let's look at here. We will borrow 3 bits from the host. Why? Because 2 to the power 3 is 8. So if you less than that, it doesn't work. Borrowing host bits means putting them in the network bits, and you need to form the networks. Borrowing bits will increase, we already know that, the network, and decrease. So there are 8 host bits according to what we have here, and there are 24 network bits. So according to the formula, if you put 2 to the power n is the number of borrowed bits, so that will form 8 networks. So if you borrow 3 bits, out of 8 host bits, you will be left with 8 minus 3, 5 host bits, okay? You will be left with 8 minus 4, 5 host bits. So I can type here, if you borrow 3 bits out of 8 host bits, okay, you will be left with 5 host bits. Now /24 will become /27, /24 will become /27. The difference is in the 4th octet, of course. So if you look at here, so in this case I borrowed 3 bits. Look, bit has to be borrowed. So if you see here, /24, it is always coming from left to right, right? Left to right. So if you are making it /27, it has to be from left to right. You cannot borrow from any other. It has to be always from the borrowing bit will have to be always from the left hand side, okay? Not from the middle or not from the right. Very important. Write it here. Note, you can only borrow bits from the leftmost host bits, okay? Not from anywhere else. Let me just grab this one. Let me see if I can put it somewhere. Okay, now look at here very carefully. Once you borrowed bits, this is the network portion, this is the network portion, and let's say this is the host portion. This is the host portion. That is the network portion, and this is the host portion. Okay. Now, if you look at here, these things are going to be changed. Okay, these things are going to be changed. Okay, so if you look at here, we have 3 network bits and host bits, 5 host bits. You can make changes only in the host portion. There is no change in the network portion. According to the formula of the network address and broadcast address, you will find these are the network addresses. Now look at here. This is the network address and this is the broadcast address, usable. Now, according to the formula of usable host is 2 to the power 5 because you have 5 host bits minus 2. So you have 30 usable IP address. If you look at here, from 1 to 30 usable, 33 to 62 usable. So you have 30 usable. The first address is the network address, last address is the broadcast address. This cannot be assigned, so that is why we subtracted 2, because usually, like, we had total 32, we could produce total 32, but we subtracted the network address and broadcast address, which is minus 2, so you have 30 usable hosts. Network addresses should be even numbers. According to the previous formula, broadcast address are odd numbers. If this doesn't match, but 0, network address could be 0 as well. Okay, so it could be 0 as well. So it will be 0 anyway. Okay, now example 3. So we have this and you need to produce 16 subnets. So we need to borrow 4 bits. So if we borrow, there are 8 host bits, 24 network bits. If we borrow 4 bits, it will produce 2 to the power 4, 16 networks. So you'll be left with 4 host bits. The cider /24 will become /28 because you have given 4 bits from the host portion to the network portion. The difference happened in the 4th octet. Okay, so this is the final time I'm showing you. So if you look at here, 8 bits first octet, 8 bits second octet, 8 bits third octet, 8 bits last octet. So usually when it is /24, it is like that. Now what's going to happen? You are making it /28. That means, sorry, I think I got out of the line. So if you are making it /28, that means this 8 bits is going to divide 4. Okay, you have 4 network bits and 4 host bits. That is why you get /28. Now look at here very carefully. We have borrowed 4 octets. So this is the first 4 is your network portion, and the last 4 is your host portion. Okay. The first 4 is your network portion and the last 4 is your host portion, and you will see the changes always happen in the first 4. Okay, is always in the first 4. The last 4 always remain the same. Okay, is always remain the same. And if you look at here, we were able to produce 16. We were able to produce 16. Now if you look at here, if we see first time we borrowed 2 bits and we were able to produce 4. Last time we borrowed 3, we produced 8. Now we are borrowing 4, we are produced 16. So actually these are the networks that you can produce. So even if you have requirements where you need 10 networks, you need to go with 4, 16. So you will have 6 extra. Okay, you'll have 6. You cannot do anything. So it cannot be exact match. It cannot be an exact match. It can be an exact match. For example, here now we have an exact match. So it can be an exact match, but if it doesn't, it is okay as well. Okay, it will not be always an exact match. Now, we got this one, and it will be very important. Previously it was /24. Now it will become /28. Very important. Okay. Now look at here. So this is the network address. So once you have until this portion. So until this portion is is /28. Now if you make all the 4 bits zeros and all the 4 bits ones, okay, so you will get the network address and you will get the broadcast address. In between are the usable hosts. Now in the exam, if you get a question, what is the first usable host? Let me write here. First usable host. .192.168 dot. So it started with 10. So you need to make sure the 10.1. This is the first usable host for one network /26. Again, if I come to the other network here, if I speak from first usable host, from the second one is .17. You see, again, first usable host from the third one is .33. They are in different networks. So they are the first usable host from different networks. Okay. Now look at here. You are left with 4. Each subnet has 4 host bits. Okay. So each subnet has now 4 host bits. So according to the formula 2 to the power 4, these are the usable IP addresses for each of them: network address and broadcast address. You cannot assign them to the users. Okay, you cannot assign them to the users.